Okay, so today we're going to talk about graphing inequalities. Graphing inequalities is very similar to graphing lines like we've been doing. There's essentially just one or two more steps depending on how you look at it. So consider problem 4 from our homework. It says y equals, it's not equals. That's the whole point of the lesson, right? Y is less than negative 7x plus 3. The first step to doing an inequality is to graph it as if it was y equals negative 7x plus 3. I'm going to do this part kind of fast. If you need help, go back last week and watch the videos on graphing. All right, so we start at the point 0, 3, because this is the y-intercept. We then look at our slope, which we see as negative 7. Keep in mind, there's always an imaginary 1. So we're going to rise negative 7. 1, 2, 3, 4, 5, 6, 7. Is that 7? 1, 2, 3, 4, 5, 6, 7. Good. And we're going to run 1. Okay. I'm not fully confident that's correct. I think I miscounted. We're going to run to this point right here, okay? That's enough to go ahead and sketch in our line. Oop, that's an ugly one. I'm going to try again. Okay. All right. Now take a second and think back to when we were doing equations with inequalities. What did our answers look like when we did those? They looked like interval notation, remember? Which was basically saying that there are many answers that could satisfy this. When we graph inequalities, the same is also true. For example, we could pick the point 0, 0. If we plug in 0, 0 for x and y, we get 0 is less than or equal to negative 7 times 0 plus 3, which if we do some arithmetic, we see that that's the same thing as 0 is less than or equal to 3. That is true. That is a true statement. 0 is less than 3. Okay? Let's pick just one other point at random. Let's pick this point right here. That is negative 4, negative 3. I just pulled that one out of my imagination. Let's just go ahead and plug it in and see if that is also a true statement. Negative 4 is less than or equal to negative 7 times negative 3 plus 3. Well, let's doing some really quick arithmetic. We see that that's going to be 21 plus 4, which is going to be 24. We have negative 4 is less than or equal to 24. That is also true. Great. Let's pick just another point right over here. Let's try this one right here. That's 4, 1. Let's just plug that in and see what happens. 1 is less than or equal to negative 7 times 4 plus 3, which is the same thing as negative 31 and 1. Is 1 less than negative 31? That's incorrect. That doesn't work. When we graph in inequalities, our answer is actually a shaded region. Our answer is a shaded region. Meaning, the answers that work in this case are the ones on this side of the line. So we have to shade that region, indicating that the ones on the left side of the line are the ones that actually work. I recommend that the easiest way to figure out where your answer is to plug in a point. and 0, 0 is the easiest point to use. The reason being, it makes the math easy later. Let's try one more example. Let's do number 1 from your homework. We have y is less than negative 2/3 x plus 5. So we go ahead and sketch that in really quick. I'm just going to graph the line. Super speed 1, 2, 3, 4, 5. We go down 2 over 3, down 2 over 3. That's enough to make our line. Okay, at this point, let's plug in 0, 0. I'm going to do that in yellow. 0 is bigger than negative 2/3 x plus 5. Well, x is 0. So now we have 0 is bigger than 5. Is that a true statement? No. So we have to shade the side that doesn't include 0, 0. So if 0, 0 is right there, we have to shade the other way, indicating our answer goes that way. So I've got one more thing to say about this. Notice what happens if we plug in a point that's on the line. In this case, 0, 5. Well, let's just try it and see what happens. 5 is bigger than negative 2/3 times 0 plus 5. Well, negative 2/3 plus 0 is 0. So we have 5 is bigger than 5. That's not true. That's not a real thing. So notice, what doesn't this have? It doesn't have the equal to here. So how we notate that it isn't equal to this is it looks something like this. You have to go and put in a dotted line. I'm going to do it in black. A dotted line to say that that isn't included. It's very similar to when we don't shade in the dot when we're doing inequality problems on a number line. So that's the last rule. And it follows very strictly. If it's less than or greater than, it's a dotted line. If there's a solid line underneath it, it's going to be a solid line. Anyway, that's all you need to know for this particular problem. Honestly, they're not too bad. They're not too bad. It's just one more thing on top of graphing the lines. Email me as always if you have any questions, and good luck with your